Your shop already uses a Redis stream for order events. Checkout appends each sale, and a background worker reads the stream and sends confirmation email. Then traffic spikes. Orders arrive faster than one worker can process them, so you add a second worker. That helps throughput, but it also creates a new problem. You need Redis to split the work fairly, so two workers do not grab and process the same order. With a single worker, it is fine for that worker to remember the last stream itself and keep reading forward. Add a second worker that also tracks its own cursor independently, and coordination breaks down. Both workers might process the same order, or one might race far ahead while the other falls behind and skips work. Consumer groups fix this by moving progress tracking into Redis, so the whole team shares one coordinated view of what has been delivered. Before the workers boot, you create a consumer group on the order stream. You give the group a name, such as workers, and you choose where reading should start. You can start from the beginning if you want to process any backlog already on the stream, or from $ if you only want orders that arrive after the group is created. This is a one-time setup step. After that, every worker process joins the same group, but each worker uses its own unique consumer name. Checkout stays simple. Each completed sale appends an order-placed event to the stream and immediately returns a response to the customer. Multiple services can append to the same stream. Workers in the consumer group pull entries in the background. The customer never waits for email delivery on the checkout path, because the stream buffers the work until a worker is ready to process it. Workers read from the group using read from group, passing the group name and a stable consumer name. The greater than position means give me entries that this group has never delivered before. Redis assigns order A to worker 1, then order B to worker 2, and so on. Under normal healthy operation, two workers in the same group do not both receive the same new stream entry. Getting an entry from the group is only the start of the job. Worker 1 sends the email, updates any read models or database state, and only then sends an acknowledge command. That removes the entry from the pending list and marks the work as complete. If the worker crashes before it acknowledges, the order stays in pending. It is not lost, but it is also not finished, and another worker can pick it up later. Now suppose worker 1 dies in the middle of sending email. Order B is still sitting in the pending list, owned by a consumer that is no longer running. The pending command shows which entries are unfinished, which consumer owns them, and how long they have been idle. After an idle timeout, such as 60 seconds, worker 2 can reclaim that entry and finish the job. Without a reclaim loop like this, stuck pending entries can block throughput indefinitely. Consumer groups give you at least once delivery, not exactly. Once magic. Worker 1 might successfully send the email, crash before it acknowledges, and then worker 2 processes the same order again. Your application code needs to handle that safely. Common approaches include database-unique constraints, a store of already processed event IDs, or side effects that are naturally safe to repeat. Redis gives you reliable handoff. Your handler gives you correct business semantics. Here is the production loop in one place. Create the consumer group once. Checkout keeps appending order events. Workers claim new entries with read from group, process them, and acknowledge on success. A background reclaim loop picks up idle pending entries after crashes. Block the read with a timeout so workers sleep efficiently until work arrives. Watch pending depth the same way you watch queue length. And trim the stream so memory stays bounded while still leaving enough history for lagging consumers. Next Redis lesson drops soon. Subscribe so you don't miss it.